and then you can come back and work. So on 4.2, the projectile is fired vertically upward with an initial velocity. Initial velocity, that's abbreviated. If you watch the notes, that's V sub naught of 96 feet per second from a tower 256 feet high. Well, that is your initial height. So the equation for this, and we're talking in feet per second, is going to be that S of t is going to equal, and it's always negative, when you're talking feet, always negative 16 t squared, and then plus the initial velocity, which is 96 t. Now that would have been negative. If it had been fired downward, that'd be a negative. And then plus S sub naught, which is 256. So that's my position function. Now, we're talking vertical position, so this is S of t is the height this object is above the ground at whatever t time. How long will it take for this projectile to reach its maximum height? Well, when you take something and it goes up in the air, it's going to eventually come back down, right? So we want to know what this maximum height is here. Well, that happens to be where the derivative or the slope is 0. So in this case, the derivative of position is velocity. We want to find when the velocity is 0. So what I need to do is I need to tell somebody that, hey, that's me, so you're telling, or the person grading it later on, is that S prime of t is equal to V of t. So that's going to give me negative 32t plus 96. So then I know that I want to find out when that thing stops going up and stops and starts coming down. So I got to find out where negative 32t plus 96 is going. Wait, I put 96. That's wrong, people. No, it's not. It is right. Plus 96 equals 0. So you add 32t over. And you divide by 32, and you get it 3 seconds. So at 3 seconds, when that thing's going to reach its maximum height. Now, have we told what the, oh, that's what we want, right? How long will it take the projectile? So projectile reaches max height at t equals 3 seconds. What's the maximum height? Well, which thing gives me height? S of t. So we know it reaches at 3 seconds, so we're going to get S of 3, which is going to equal negative 16 times 3 squared plus 96 times 3 plus 256, and that is feet. So that can be your answer. Anybody want to type that in your calculator? 400 feet. So it gets a max height of 400 feet at t equals 3 seconds. How long will it take the projectile to reach its starting position on the way down? Well, in this particular thing, we're starting up here at 256 feet, right? And we go up, and then it comes back down, so it's going to hit. It's going to hit over here, 256 feet on the way down here to the ground, right? So what am I going to do? It says how long, so I'm looking for what? Which variable? T. I'm looking for t, and I want to get t when the height's what? What? 256. So I'm going to say 256 equals negative 16 t squared plus 96t plus 256, because I want it to reach that same height over here. So I subtract 256 from both sides and get 0. Then I'm going to factor out a negative 16t from both parts. So that's going to be a t minus, and that, what is that, 6? I think, right? 96 divided by 16 is 6. So t equals 0. Well, that's when the projectile was fired, and then t minus 6 equals 0 gives you t equals 6. That's when it gets to the same height. So you should say at 6 seconds, the projectile reaches the same height as the starting position. Everybody, are we all? Yes.
So if it reads in the same spot it started, can't you just multiply where it started to get to its max height times t? It's gotta go to its max height and come down, and it stays at the same velocity.
Well, in this class, that will probably work most of the time. Sometimes in physics, you gotta be careful because you got outside objects working on it.
Okay.
So I still think you should put it in that way and do it and show your math.
Okay.
What is the velocity of the projectile when it passes its starting point on the way down? So now we're looking for velocity. So we want v of what? V of what? V of 6, because we're looking for that value. And we did v up here, right? So this is going to be negative 32 times 6 plus 96. Now, that right there can be your answer. Now, isn't velocity the derivative or slope of position? So position, the s value's in what? Feet. And the x or t is seconds, so this answer is feet per second. Now that can be fine. That could be fine for your answer right there, but what's this going to be if we calculate it out? Negative 96 feet per second. Now, who can tell me why it's a negative? Anybody know why it's negative? Yeah?
It's going down.
Yeah, the object's falling towards the earth. Whenever everything's going down, it will have a negative velocity. How long will it take the projectile to hit the ground? Okay, so we're looking for long. That's time again. How high is the ground? 0. So we got to come over here and we got to plug 0 in. And now we want to find that value. Now to save some time, I always like my quadratic. I always like it being a positive leading coefficient. So I'm going to multiply each side by -1 right now. And then I'm willing to bet that 256 is divisible by 15. So I'm going to divide every single term by 16 now to simplify my problem. I believe that's what I get. So now I'm going to try to factor that to find out the 2 times that the object would be on the ground. So t equals 8 and t equals -2. What's wrong with -2? You don't go back in time, right? Now look up here at my picture. See, if I took this picture, we took it and we started right here. That was times 0, right? So there's actually a y-axis right there. But if you took this parabola down here, that means it would have been a -2 down here in time if we finish that off. So we don't worry about going back in time. So the answer would be at t equals 8 seconds, the object would hit the ground. What will the speed, oh, there's a word, speed be when it hits the ground? What speed? What about velocity? Something special about velocity? No. It's the absolute value of velocity. The absolute value of velocity equals speed. So we're going to do the absolute value of v of 8, which is going to equal the absolute value of -32 times 8 plus 96. Will someone tell me what -32 times 8 plus 96 gives you? You want me to work it out? Okay, I'll work it out. That's -16, carry 1, -256 plus 96. So that was 100, that'd be -156. All right, 156, if that was 100, so it'd be what, -160, right? But it's an absolute value. So the speed when it hits the ground would equal 160 feet per second. So the projectile would be traveling at 160 feet per second when it hits the ground. So that's number 12. We're going to go over and do 15. The velocity of a particle moving along the x-axis is this graph. So this is velocity. So I'm going to put v of t up here. It's already right there, but I'm going to write it again. And this is going to be time, because t is what's inside the parentheses. Along the x-axis shown in the figure to the right, with t measured in seconds. Later in this course, you will learn ways to justify each response as well as find how far the particle has traveled. At what time is the particle farthest to the right? So this object is going to it's starting somewhere, it's going right, it stops for an instant, and then it starts going left again until it stops again. So what do you know about velocity and moving right and left? What's velocity when an object is moving right? This is in your notes. What's velocity? Greater than 0, positive. What's velocity when it's moving to the left? Negative, moves left. And what's velocity when it's not moving? Velocity equals 0 is stopped. Where's this object stopped? Remember, this is velocity. Where's it stopped? Right here. And right there it stopped. Now, what's velocity if it's above the x-axis? Anybody know? Okay, up here it's positive, right? Aren't these y values positive, v of t values positive? So up here, v of t is greater than 0, but down underneath, aren't these negative values for v of t? So at what time is the particle farthest to the right? So this means it's moving, it starts somewhere and it's moving right, stops, starts going left, stops. So at what time will the particle be furthest to the right? T equals what? I'm going to call it 3. Because even though it stops, it's still to the furthest right. At what time is the interval speeding up? Okay. What two things do you look up for speeding up and slowing down? What? Acceleration and velocity. If they have the same signs, they are speeding up. If they have different signs, they're slowing down. In other words, one's positive, one's negative. So, what is acceleration compared to velocity? We just put it on the last problem. What's acceleration compared to velocity? What? The derivative, which is another name called the what? Slope. All right, so let's look at this. What is the slope from right here going all the way down to right there? What's that slope? So A is less than 0 there. What is the slope from right here going all the way down until I get to that lowest point? What's the slope there? A is less than 0. What's the slope on this side as I'm going up to there? Positive. So I'm looking for where's velocity and acceleration, because all I want speeding up, I want them to have the same sign. So here, acceleration's negative, velocity's positive. So from here to here, we're slowing down. From 0 to 3, it's slowing down because the signs are different. Here, velocity's negative, acceleration's negative. What's happening here? So on the interval from 3 to 4, 5, 6, that looks like 7 to me. Would you agree with that? 3 to 7, the particle is speeding up. We're going to go ahead and tell the reason, because A of t is less than 0 and V of t is less than 0 on that interval. Is there another one down below there? Nope. Okay, so there's the two problems you wanted. It's about time for lunch, so we're gonna shut this down. I'm gonna have this up on the screen before we get back, I hope, or up on the canvas.